Have you ever imagined what it would be like to look to the sky one ordinary day and see a giant shadow cast by a visitor from space threatening the very survival of our planet? Today, we're not just talking about science fiction or Hollywood movies. We're diving into a real-life cosmic drama that might unfold in the year 2029. Enter Apophis, the colossal asteroid named after the Egyptian god of chaos. It's an astronomical giant that, according to experts, might be on a collision course with our Earth. In this video, we'll explore how this giant rock poses a threat to our safety and what it means for our future. Stay with us as we navigate the thrilling journey of Apophis, the asteroid that could redefine everything we know about life on our planet. In the annals of astronomical discoveries, the year 2004 stands out as a significant moment when scientists detected an extraordinary object hurtling through space. This object, later named Apophis, was first spotted by astronomers Roy A. Tucker, David J. Tolan, and Fabrizio Bernardi at the Kitt Peak National Observatory in Arizona. As the observations poured in, initial calculations of Apophis's orbit suggested a startling possibility, a potential collision path with Earth. The scientific community was jolted into action. This was no ordinary discovery. Using the powerful tools at their disposal, astronomers employed techniques such as radar imaging and optical telescopes to meticulously track its path. These techniques allowed them to capture detailed data on the asteroid's distance, speed, and trajectory. As more data became available, the preliminary findings indicated an unsettlingly close approach in 2029. The immediate concern was undeniable. Apophis was not just another dot in the sky, it was a potential threat that could have catastrophic consequences. As scientists closely monitor this cosmic visitor, it serves as a humbling reminder of the unknowns that lie beyond our blue planet and the relentless efforts required to keep watch over our celestial neighborhood. The characteristics of Apophis present a fascinating yet daunting picture of this cosmic traveler. Measuring approximately 1,150 feet in diameter, Apophis is roughly the size of the Eiffel Tower. This gigantic mass hurtles through space at an astonishing speed of about 30,000 miles per hour, a velocity that underscores its potential for devastating impact. Unlike many other asteroids, which are composed primarily of rock and metal, Apophis is believed to have a complex composition including a diverse mix of nickel, iron, and silicate materials. This composition not only makes it dense but also increases its potential for destruction. When compared to other known asteroids like the Chicxulub impactor, which led to the extinction of the dinosaurs, Apophis stands out due to its relatively large size and energy potential. While Chicxulub was over 6 miles wide, Apophis, although smaller, still carries enough kinetic energy to cause significant damage upon impact, particularly in densely populated areas. Its sheer size and speed make it a subject of intense study and concern among astronomers. The possibility of Apophis creating a substantial impact event is not just a speculation of science fiction. It is a real scenario that scientists are diligently trying to prevent through continuous observation and research. Understanding its characteristics helps astronomers prepare better for potential deflection techniques should the need arise as we edge closer to the year 2029. The orbital path of Apophis has been a subject of intense scrutiny and meticulous calculation ever since its discovery. As we inch closer to that critical year of 2029, understanding its trajectory becomes paramount. Apophis follows a highly elliptical orbit around the Sun, moving in a pattern that brings it remarkably close to Earth's path. This orbit is not merely a straight line. It twists and turns influenced by the gravitational forces of the celestial bodies it passes. Imagine a cosmic dance with Apophis moving rhythmically in space, sometimes closer to us, then retreating further into the solar system, only to return again. For years, scientists have employed advanced computer simulations to predict its precise trajectory. analyzing the gravitational tugs it experiences from planets, the Sun, and small forces like the Apophis effect caused by sunlight. These simulations create a detailed picture akin to a high-tech cosmic map, ensuring we understand where and when Apophis will travel. In 2029, Apophis is predicted to make an extraordinarily close approach to Earth, passing within a mere 19,000 miles of our planet. To put this in perspective, this distance is actually closer than some of the geostationary satellites orbiting Earth. Such proximity highlights the importance of accurate predictions and the potential need for rapid response strategies. Diagrams depicting Apophis's path show a complex interplay of celestial motion, illustrating how close and yet how delicate our position is within the grand scheme of the universe. By observing and learning from Apophis's journey through space, astronomers can refine their methods, not only for this immediate threat, but for any future celestial object that may pose a risk. The continuous monitoring and study of Apophis's path are crucial components in the broader effort to safeguard our planet from cosmic hazards, reminding us of the delicate balance we maintain in this vast universe. The evolving probability of Apophis impacting Earth has been a riveting topic in the scientific community, capturing the attention of astronomers worldwide. Initially, when Apophis was discovered, calculations alarmingly suggested that there was a 1 in 37 chance of an impact in 2029. This sparked both urgency and curiosity, leading researchers to refine these predictions with more data and advanced models. Over time, as scientists gathered more information, the probability was thankfully adjusted downwards. The current assessment is that the chances of a collision are exceedingly small, yet this does not mean that our attention can wane. The journey to these revised probabilities was not straightforward. It involved addressing significant uncertainties inherent in such cosmic calculations. The factors influencing these predictions include the limited initial observational data and small forces like the Apophis effect, which arise from thermal emissions that can subtly alter an asteroid's trajectory. To enhance the accuracy of their estimates, astronomers employ radar observations from facilities like the Goldstone Observatory and the Arecibo Observatory before its unfortunate collapse. These facilities provided precise measurements of Apophis's size, shape, and spin state, all crucial for refining its path prediction. Additionally, the International Asteroid Warning Network plays a pivotal role, ensuring continuous global collaboration and data sharing. Despite current predictions showing a low likelihood of impact in 2029, these efforts underscore a broader commitment to planetary defense. They highlight the dynamic nature of space studies and our ever-improving ability to predict and respond to cosmic threats. Understanding the uncertainties in these estimates teaches us the value of vigilance and preparation, reminding us that while the sky is vast, the tools to understand it are within our reach, providing reassurance as we look towards the future with both caution and hope. The potential impact zone of an asteroid like Apophis is a subject of both scientific speculation and serious concern. Based on its current trajectory, experts predict several geographical areas that could be at risk in the unlikely event of an impact. While pinpointing an exact location is challenging due to the numerous variables at play, general predictions suggest that regions along the equator could be particularly vulnerable due to the asteroid's path. The consequences for these areas are manifold. Firstly, an impact in a densely populated region could result in significant loss of life and infrastructure. Consider a potential collision near a coastal city. The immediate destruction could be accompanied by catastrophic tsunamis, devastating communities both locally and across vast distances. The ecological impacts would be equally severe. An impact on land could lead to widespread fires, air pollutants, and potentially a nuclear winter scenario where the sun is blocked out by debris, affecting global climates and agriculture. River ecosystems might face contamination, while terrestrial habitats could be irreparably damaged, leading to loss of biodiversity. Economically, the effects would resonate globally. Aside from the direct costs of rebuilding and humanitarian aid, there would be ripple effects on global trade, supply chains, and markets. Insurance losses would skyrocket, and economies reliant on affected regions could face recession. This scenario underscores the importance of advanced prediction technology and international cooperation in preparing for such possibilities. Awareness and preparedness are critical as they allow for the development of evacuation plans, infrastructure fortification, and effective international response efforts. Although the chances of an Apophis impact are low, exploring these potential scenarios ensures that we do not underestimate the importance of planetary defense and our responsibility to protect the fragile ecosystem we call home. The historical precedents of asteroid impacts provide a sobering reminder of Earth's vulnerability to cosmic events. One of the most famous examples is the impact that occurred 66 million years ago, which is believed to have led to the extinction of the dinosaurs. This catastrophic event was caused by a massive asteroid, approximately 6 miles in diameter, that struck the Yucatan Peninsula, leaving the Chicxulub crater. The aftermath was devastating, with the impact generating massive shockwaves, volcanic activity, and tsunamis. Dust and debris filled the atmosphere, blocking sunlight and causing a dramatic drop in temperatures, leading to what scientists call an impact winter. This drastic climate change disrupted ecosystems and food chains globally, resulting in the extinction of roughly 75% of species on Earth. Other notable events include the Tunguska event in 1908, where a smaller asteroid exploded over Siberia, flattening trees over an 800 square mile area. Although no crater was formed and no human casualties reported, the immense energy release equivalent to 15 megatons of TNT highlights the potential for damage even from smaller space objects. These examples underscore the potential consequences of an Apophis impact should it occur. While current estimates suggest a low probability of a collision, the historical record serves as a stark warning. It emphasizes the importance of vigilant monitoring, robust planetary defense strategies, and international cooperation to mitigate the risks posed by these cosmic threats. By learning from the past, we equip ourselves with the knowledge and preparedness needed to protect our planet and ensure the safety of future generations. Global response and preparedness for the potential impact of Apophis involve a remarkable display of international collaboration and strategic planning. Organizations like NASA and the European Space Agency, or ESA, are at the forefront of these efforts, employing cutting-edge technology and expertise to tackle this cosmic challenge head-on. NASA Planetary Defense Coordination Office plays a critical role in detecting, tracking, and characterizing near-Earth objects, focusing its resources on identifying any potential threats like Apophis. This office coordinates efforts across various agencies and integrates global data to ensure a comprehensive understanding of the risks involved. Meanwhile, ESA has launched the Space Safety Program, which includes missions like HERA, designed to gather crucial information on asteroid behavior and potential mitigation techniques. The synergy between NASA and ESA exemplifies the spirit of global teamwork needed to address such planetary threats. This cooperation extends beyond these agencies, involving the International Asteroid Warning Network and the Space Mission Planning Advisory Group. These networks foster information exchange and develop joint strategies to enhance the effectiveness of planetary defense initiatives. Strategies being explored include kinetic impactors, which are spacecraft designed to collide with and change the trajectory of an asteroid, and gravity tractors, or spacecraft that use their gravitational pull to nudge an asteroid onto a safer path. Nuclear options, while considered a last resort, remain a topic of research for potential deflection or disruption of more massive objects. These efforts underscore the importance of preparedness, leveraging technological advances and global partnerships to protect our planet. The coordination among nations and organizations reflects a shared commitment to safeguarding Earth, illustrating that when humanity unites toward a common goal, we stand a much better chance in the face of cosmic uncertainties. As we advance towards the year 2029, ongoing observation and collaboration remain crucial in ensuring we are ready to address any eventualities posed by Apophis or other celestial challenges. This proactive stance not only strengthens our defenses, but also serves as an inspiring testament to our collective ability to confront the potential threats of the universe. Mitigation techniques for deflecting or mitigating an asteroid impact are at the forefront of current scientific exploration and development. Imagine an advanced arsenal designed specifically to protect our planet from the potential collision with space rocks like Apophis. One of the primary mitigation strategies involves kinetic impactors. This technique uses a spacecraft to collide with the asteroid at high speed, changing its trajectory just enough to steer it away from Earth. The idea is similar to playing billiards in space, where precision is key, and even a slight nudge could significantly alter the asteroid's path. Meanwhile, gravity tractors offer another intriguing solution. Picture a spacecraft hovering near the asteroid without making contact. By utilizing its own gravitational pull, the spacecraft gradually shifts the asteroid's course. It's a slower process, relying on the subtle force of gravity over time to achieve the necessary deflection. While more complex in execution, gravity tractors provide a non-destructive means to redirect these space objects. Then there's the powerful option of nuclear detonation. Unlike what movies might depict, the aim is not to obliterate the asteroid, but rather to detonate a nuclear device near its surface, thereby altering its trajectory with the explosive energy released. This technique demands utmost precision to ensure the asteroid isn't shattered into multiple hazardous fragments. The nuclear approach is considered a last resort, primarily due to the potential risks and challenges associated with nuclear deployment in space. Collectively, these techniques form a dynamic toolkit for planetary defense, representing the cutting edge of human innovation and ingenuity. As we refine these technologies, international collaboration and rigorous testing are essential to ensure they can be effectively implemented when needed. The ability to anticipate and respond to potential asteroid threats not only secures our future, but also exemplifies the boundless capabilities of human achievement when faced with cosmic challenges. The role of technology in prediction is a cornerstone of our ability to understand and mitigate the risks posed by asteroids like Apophis. At the heart of this capability is modern technology, which has revolutionized the way we track and predict the paths of these celestial travelers. Advancements in telescopic and radar technologies have dramatically enhanced our capacity to observe and analyze objects in space. Telescopes, once limited to terrestrial observations, are now complemented by powerful space-based telescopes like the Hubble Space Telescope and the much-anticipated James Webb Telescope. These instruments provide unparalleled views of asteroids, capturing data on their size, shape, and movement with extraordinary precision. Radar technology further enriches this picture. Ground-based radar systems, such as those at the Goldstone Observatory, emit radio waves that bounce off asteroids, allowing scientists to map their surface features and refine orbital paths. This radar imaging not only improves trajectory predictions, but also contributes to our understanding of the asteroid's spin, speed, and composition. The fusion of these technologies equips scientists with a comprehensive toolkit, enabling them to detect potential threats much earlier than before. With more data comes improved models and simulations, which allow researchers to make accurate predictions about an asteroid's path years or even decades in advance. This foresight is crucial in developing strategic responses and mitigation plans, significantly reducing the risk of unforeseen impact scenarios. The continuous investment in technological advancement underscores a broader commitment to planetary defense, ensuring that we are not merely passive observers of our cosmic neighborhood but active participants in safeguarding our planet. As we look towards the future, the synergy between technology and science promises to deepen our understanding of space, fostering a sense of readiness and resilience against the challenges that lie beyond our atmosphere. Public perception and misconceptions about the threat posed by Apophis have been shaped significantly by how media and public narratives are constructed. For many, asteroids immediately conjure images of blockbuster movies filled with dramatic destruction and last-minute heroics. While these portrayals capture the imagination, they often blur the line between reality and fiction, leaving the public with sensationalized ideas about astronomical threats. This can lead to inflated fears or, conversely, skepticism about the seriousness of genuine threats. A common misconception is that an asteroid like Apophis will inevitably cause catastrophic damage, with some believing we are powerless against such space phenomena. In reality, scientists and space agencies have made tremendous strides in tracking and predicting the paths of asteroids, developing advanced techniques capable of preventing potential collisions. Misunderstandings can also arise from the complex scientific language used in astronomical studies, which may not always be conveyed clearly in mainstream media. This is where scientists play a crucial role. By actively engaging with the public through educational outreach and transparent communication, researchers help demystify the science behind asteroid tracking and defense strategies. They provide clarity on probabilities, potential impacts, and the innovative solutions being implemented globally. Efforts to educate the public also focus on fostering a balanced perspective, highlighting both the real risks and the proactive measures in place to safeguard our planet. By doing so, they aim to prevent unnecessary panic and encourage a scientifically informed dialogue. As we approach the year 2029, the task remains to bridge the gap between scientific understanding and public awareness, ensuring that while the threat of Apophis is taken seriously, it is viewed through a lens of reason and preparedness rather than fear. The societal impact of knowing that an asteroid like Apophis might hit Earth can be profound, affecting both individual psyches and community dynamics. Imagine your daily routine interrupted by a looming celestial threat. The psychological effect alone is significant. People might experience heightened anxiety and stress as they grapple with the idea of a potential impact. This awareness may lead to heightened awareness of our planet's vulnerability, prompting discussions about preparedness and resilience. Communities might begin to band together, forging stronger connections as they prepare collectively for any eventualities. This could be seen in local governments enhancing emergency response plans or offering public seminars to educate residents about potential threats and safety measures. There may also be a shift in public attention toward scientific research and technology aimed at planetary defense. People might become more conscientious of the need for space observation and support initiatives that fund research into asteroid deflection techniques. Such societal shifts might manifest in increased public interest and participation in community readiness programs, emphasizing the importance of being prepared for unexpected events. Long-term, this awareness could alter human behavior, encouraging a more sustainable and cooperative approach to living on Earth. It might even inspire a new generation of scientists and advocates dedicated to understanding and protecting our planet from cosmic risks. As the world watches Apophis's approach, the shared experience could unify communities globally, fostering a sense of collective responsibility that extends beyond borders, reminding us of our shared fate and the interconnectedness of all humanity. The science of asteroids is an intriguing field that opens a window into the ancient history of our solar system. These rocky bodies, often described as leftover building blocks from the planet formation process, originate primarily from the asteroid belt located between Mars and Jupiter. This region is home to millions of these space rocks, remnants of a primordial disk of dust and gas that failed to coalesce into a planet due to Jupiter's immense gravitational influence. Asteroids exhibit diverse compositions, often determined by their location within the asteroid belt. They can be composed of metals, silicates, or carbon-based materials. Some contain rare minerals and metals like platinum, adding to their scientific and economic interest. Understanding the composition of asteroids is crucial, as it offers insights into the conditions and processes that shaped the early solar system. A common distinction between asteroids and other celestial bodies like comets lies in their composition and location. Comets, in contrast, originate from the icy regions of the solar system and are composed mostly of ice mixed with dust and organic compounds. This composition gives them their characteristic glowing coma and tail when they approach the sun, as the heat causes the ice to vaporize. Meteoroids, on the other hand, are much smaller fragments often derived from asteroids or comets. When a meteoroid enters Earth's atmosphere and burns up, it creates a meteor or shooting star. If it survives the journey and lands on Earth, it is then termed a meteorite. This differentiation highlights the richness and variety of small celestial bodies within our solar system, each offering unique clues to our cosmic history. As we continue to study asteroids through missions like NASA OSIRIS-REx, which aims to bring a sample of an asteroid back to Earth, we edge closer to unlocking the mysteries of our solar neighborhood. These studies not only enhance our understanding of the solar system's evolution, but also prepare us for potential future utilization of asteroid resources. By learning more about the science of asteroids, scientists are not just unraveling the past, but also paving the way for future exploration and the possibility of using these celestial bodies to support space missions and even life beyond Earth. The impact on space policy is profoundly shaped by the looming threat of Apophis, as it prompts a re-evaluation of priorities in international space agendas. Governments and space agencies worldwide are increasingly realizing the significance of reallocating resources towards asteroid tracking and deflection missions. Historically, space policy has often focused on exploration, satellite deployment, and scientific study, but the potential risk posed by Apophis has catalyzed a shift toward planetary defense. This shift is evident in increased funding and collaborative initiatives dedicated to detecting and tracking near-Earth objects. Countries are now more inclined to prioritize technological advancements that enhance our ability to chart the paths of potentially hazardous asteroids like Apophis. The potential impact of Apophis underscores the urgency for developing effective deflection strategies. As a result, investments are being channeled into research and development of kinetic impactors and gravity tractors. These efforts are paralleled by a push for international treaties and agreements that facilitate joint efforts in space technology and information sharing. The possibility of a cosmic threat has sparked discussions about the necessity for a unified global policy, where nations pool resources and expertise to bolster our planetary defense systems collectively. This renewed focus not only aligns space policy with contemporary threats, but also fosters a spirit of international cooperation and solidarity, emphasizing shared responsibility in protecting Earth from potential celestial hazards. As Apophis approaches, it catalyzes ongoing dialogues in policy-making circles, driving innovations in space science and ensuring that global strategies are well prepared to meet the challenges posed by the universe's unpredictable nature. Apophis in popular culture has become a captivating subject, sparking the imagination of storytellers and audiences alike. In recent years, this asteroid has been featured in various documentaries, news segments, and even movies that dramatize the potential collision scenarios. These portrayals often lean into the thrill and drama of space threats, painting a picture of imminent danger and heroic interventions. While these stories are entertaining, they can significantly influence public perception, sometimes blurring the line between science and fiction. Documentaries often provide a more balanced view by combining scientific insights with visual storytelling, aimed at educating audiences about the scientific reality behind the headlines. These programs emphasize the collaborative efforts of global space organizations in tracking and preparing for potential asteroid threats. However, in the realm of movies and fictional narratives, Apophis is often depicted with an artistic flair that prioritizes suspense and action. Films might portray the asteroid as an unstoppable cosmic force, highlighting dramatic countdowns and last-minute attempts to avert disaster. This approach can lead to heightened public anxiety, as the gravity of the situation is amplified for dramatic effect. Yet, it can also raise awareness about the importance of planetary defense and the advancements in space technology designed to protect our planet. The influence of these cultural portrayals on public perception is profound. They can inspire curiosity and interest in space science, prompting audiences to learn more about the real-world efforts to monitor and mitigate asteroid risks. Conversely, they can also perpetuate misconceptions, leading some to either underestimate or overinflate the actual threat level. As we approach 2029, it is crucial for both filmmakers and educators to bridge the gap between entertainment and education, ensuring that while the story of Apophis captivates, it also informs and reassures the public. This balance helps foster a well-informed dialogue about space threats, encouraging a proactive approach to planetary defense while still appreciating the wonders and mysteries of the cosmos. Future observation campaigns are pivotal as we edge closer to the year 2029, when Apophis is predicted to make its close approach to Earth. These campaigns are designed to provide critical data that will enhance our understanding of Apophis and ensure that its path is accurately charted. One of the significant upcoming efforts involves NASA's continued radar observations using facilities like the Goldstone Observatory. These observations allow scientists to collect precise data on Apophis's orbit, refine its predicted trajectory, and assess any changes in its course. In addition to radar studies, there are plans to engage ground-based optical telescopes worldwide, which will offer a comprehensive observational network capable of monitoring Apophis from multiple vantage points. This collaborative global effort will ensure that no aspect of Apophis's journey goes unnoticed. The European Space Agency is also contributing to these observation campaigns through projects like the Planetary Defense Office, which coordinates with international partners to track and analyze near-Earth objects. As part of these efforts, the ESA's Fly-Eye telescope is scheduled to be operational soon, enhancing the ability to detect and monitor asteroids. The importance of continued monitoring cannot be overstated as 2029 draws nearer. Keeping a vigilant eye on Apophis ensures that any deviations in its predicted path are swiftly detected, allowing for timely updates and responses. Accurate monitoring is essential for making informed decisions about potential deflection strategies should the need arise. With each observation campaign, scientists are not only safeguarding our planet, but also expanding our understanding of asteroid behavior and dynamics. These endeavors reflect a broader commitment to planetary defense, highlighting the importance of international cooperation and scientific innovation in addressing cosmic challenges. As we look to the future, these campaigns are a testament to our readiness and resilience in the face of potential celestial threats. Simulating an impact scenario with Apophis involves using advanced computer models to understand the potential consequences and plan effective responses. Imagine a digital universe where scientists recreate virtual Earth and asteroid environments to forecast the outcomes of a possible impact. These simulations rely on a multitude of variables including Apophis's size, composition, speed, and angle of approach. By inputting these details into sophisticated software, researchers can visualize various scenarios such as the asteroid hitting land or water, as well as the resulting effects. For instance, they examine the energy released upon impact, which could be equivalent to thousands of nuclear bombs going off simultaneously. This energy release helps determine the extent of the shockwave, fires, and tsunamis that might follow. Another critical factor considered is the asteroid's composition, as this affects the fragmentation upon collision. A primarily metallic asteroid might create a different impact pattern compared to one made mostly of rock. Scientists also analyze the terrain of the predicted impact zone, whether urban or rural, to anticipate the potential damage to infrastructure and ecosystems. One potential outcome modeled is the climate effect caused by the dust and debris thrown into the atmosphere, which could block sunlight and lower global temperatures, reminiscent of a volcanic winter. These simulations, while theoretical, are invaluable as they inform preparedness strategies, enabling governments and agencies to develop evacuation plans, fortify structures, and coordinate international responses. By continually refining their models with the latest data, scientists ensure that their predictions remain as accurate and useful as possible. This proactive approach exemplifies how science and technology work hand in hand to protect our planet, demonstrating the importance of readiness in the face of cosmic threats. The economic cost of an Apophis impact would be staggering, reverberating far beyond the immediate aftermath of the collision. Imagine a scenario where the asteroid strikes a major metropolitan area. The immediate destruction would be catastrophic, with infrastructure obliterated, businesses disrupted, and essential services halted. Direct costs would include the monumental expenses of rebuilding cities, repairing critical infrastructure like roads, bridges, and communication networks, as well as the loss of life insurance payouts and healthcare costs for injured survivors. The indirect costs would be equally profound. In the wake of such destruction, the global supply chain could face significant disruptions, especially if the region affected is a key commercial hub. Industries dependent on timely imports and exports might find themselves struggling with delays, leading to shortages and inflation. The impact on global markets could be severe, with stock exchanges experiencing volatility as investors react to the instability. In addition, the long-term economic shifts might include a re-evaluation of investment priorities, with increased funding directed toward disaster preparedness and technology for asteroid deflection or detection. Economies heavily reliant on tourism might face declines as regions affected by proximity to the impact zone could see a drop in visitors, while fear and anxiety might deter international travel. Insurance companies would need to recalibrate risk assessments and premiums, potentially leading to higher costs for consumers. On a broader scale, governments might face increased pressure to prioritize space monitoring programs and invest in scientific research to prevent future disasters. This could shift economic focus from short-term gains to long-term sustainability and global cooperation. While the chances of an Apophis impact are low, considering these economic scenarios highlights the need for proactive planning and international collaboration to mitigate the financial blow of such a potential catastrophe, ensuring that economies are resilient and prepared for the uncertainties of our cosmic neighborhood. The role of citizen science has become increasingly vital in the quest to track asteroids like Apophis. Imagine ordinary people armed with telescopes and a passion for discovery, making significant contributions to our understanding of these cosmic travelers. Amateur astronomers and citizen scientists across the world play a crucial part in observing and tracking near-Earth objects. Their efforts often supplement the work of professional astronomers, providing valuable data that enhances our collective ability to monitor potential threats. These citizen scientists use their own equipment to observe the night sky, often capturing images of asteroids which are then shared with professional networks for analysis. The collaborative nature of this work cannot be overstated. For instance, in the discovery and ongoing monitoring of Apophis, amateur astronomers have consistently provided observations that help refine its orbital path. Their contributions are often collected through platforms like the Minor Planet Center, where observations are compiled, allowing for a more comprehensive picture of the asteroid's trajectory. These efforts are not just limited to professionals, they invite everyone to participate, making the study of asteroids an accessible and shared endeavor. Notable contributions from amateurs include the discovery of new asteroids and continuous tracking efforts that fill in gaps left by larger observatories. Their observations help update databases that professionals use to predict the future positions of asteroids, enriching global efforts to maintain an accurate celestial map. Engaging the public in these efforts not only aids scientific research, but also fosters a greater understanding and appreciation of planetary defense. As we approach the year 2029, there is an open invitation for viewers to participate in this fascinating area of science. Whether through joining local astronomy clubs, participating in global observation nights, or simply learning more about the skies above, citizen science represents an exciting opportunity for everyone to contribute to the safety and knowledge of our planet. By embracing this collaborative spirit, we empower a broader community to engage in the exploration and protection of our cosmic neighborhood, ensuring that we are all part of the solution to the challenges we face. The ethics of planetary defense introduce a complex dialogue, bringing to the forefront questions of morality and responsibility as we consider deflecting potential threats like Apophis. Imagine being tasked with deciding whether to alter the trajectory of an asteroid, knowing the consequences of such actions may ripple across the globe. At the heart of these decisions lies the fundamental concern of who gets to decide which path is taken and under what circumstances. The prospect of deflecting an asteroid raises serious ethical questions about the potential outcomes and unintended consequences. For instance, redirecting a space rock away from one region might inadvertently place another area in its path. This raises issues of liability and fairness, as well as the need for transparent decision-making processes. In tackling these ethical dilemmas, international collaboration and consensus are essential. Decisions regarding planetary defense need to be made by a diverse group of stakeholders, encompassing scientists, policymakers, and representatives from nations worldwide. The establishment of an international governing body or framework might be necessary to ensure that no single entity holds unilateral decision-making power over actions with global implications. This would help distribute responsibility and accountability, making sure the voices of all potentially affected parties are heard. Furthermore, there are ethical considerations regarding the methods employed to deflect an asteroid. Using nuclear devices, for instance, sparks debates over weaponization of space and the environmental impact of such interventions. The need to balance technological capabilities with ethical foresight becomes paramount, ensuring that any chosen solution prioritizes humanity's collective safety without compromising core values. As we move toward the year 2029 and beyond, these discussions emphasize the importance of a conscientious approach to planetary defense, one that prioritizes ethical principles alongside scientific expertise. By addressing these challenges collaboratively, we not only enhance our readiness to deal with cosmic threats, but also uphold the integrity and unity required to navigate such unprecedented moral territories. The 2029 close approach of Apophis is a highly anticipated event within the astronomical community. As this asteroid makes its way perilously close to Earth, scientists and organizations around the world are preparing for an unprecedented opportunity to study and engage with this celestial phenomenon. During this event, Apophis is expected to pass at approximately 19,000 miles from our planet, an astonishingly close distance that brings a rare chance for detailed observation and research. This proximity allows scientists to utilize various observation techniques, including radar imaging and optical telescopes, to gain insights into the asteroid's physical properties such as its size, shape, and surface characteristics. These observations are crucial for refining our understanding of Apophis's trajectory and any potential future threat it might pose. In addition to scientific study, the 2029 Close Approach is poised to become a significant public engagement event. Organizations like NASA and the European Space Agency are planning activities designed to educate and involve the public in this cosmic event. Live broadcasts and educational programs will be made available, allowing people around the globe to witness the asteroids flyby and learn about the science behind it. These initiatives aim to foster a deeper appreciation of planetary defense efforts and the importance of space exploration. The event also serves as a reminder of the vastness and mysteries of our universe, inviting people to engage with the wonder of observing a near-Earth object. As we edge closer to this date, the anticipation builds not only for the scientific discoveries that will emerge, but also for the global unity in our shared experience of witnessing a piece of space history unfold. This extraordinary close approach of Apophis in 2029 stands as a reminder of our planet's place in the cosmos, highlighting the importance of continued observation and collaboration in the field of planetary science. Apophis and climate change present an interesting intersection of astronomy and environmental science as we consider how an asteroid impact might influence our planet's climate. To understand this, we can draw parallels to historical impacts like the Chicxulub event, which profoundly affected Earth's climate millions of years ago. When a massive asteroid collides with Earth, it can release an immense amount of energy, leading to widespread fires and sending vast quantities of dust and aerosols into the atmosphere. These particles can block sunlight, causing a phenomenon known as impact winter, a dramatic drop in global temperatures due to reduced solar radiation reaching the surface. This cooling effect can disrupt weather patterns, alter ocean currents, and impact ecosystems similarly to what we understand about volcanic activities affecting climate. In addition to cooling, an asteroid impact could also lead to the release of greenhouse gases from burning forests and organic matter, contributing to long-term warming. The combination of short-term cooling and potential long-term warming presents a complex scenario for climate scientists. While the immediate aftermath may result in colder temperatures, the eventual introduction of carbon dioxide and other gases could exacerbate current warming trends. The lesson from past events is clear. The planetary impact of an asteroid on climate is significant and multifaceted, demonstrating both cooling and potential warming effects. These historical precedents emphasize the importance of understanding and preparing for such cosmic challenges. Although the probability of Apophis impacting Earth in 2029 is low, evaluating its potential influence on climate change underscores the need for comprehensive planetary defense mechanisms and climate resilience strategies. By examining the interconnectedness of celestial events and climate dynamics, we not only prepare for rare catastrophic occurrences, but also gain insights into the complex systems that govern our planet's climate, enhancing our ability to respond to future environmental challenges with informed and proactive approaches. Lessons from other near-Earth objects hold invaluable insights as we consider the potential threat of Apophis. By examining past encounters with these celestial visitors, we equip ourselves with a deeper understanding of the challenges and strategies necessary to safeguard our planet. One notable event that offers significant lessons is the Chelyabinsk meteor that entered Earth's atmosphere over Russia in 2013. Although relatively small, the meteor created a shockwave that injured over 1,000 people and caused extensive property damage, highlighting the importance of not underestimating even small-sized objects. This incident underscored the need for comprehensive monitoring systems that can detect smaller near-Earth objects well in advance. In response, scientists have focused on improving detection networks, enhancing their ability to spot and track even diminutive threats. By learning from Chelyabinsk, efforts have intensified globally to develop better early warning systems, ensuring that we remain vigilant against the unpredictable nature of space. Another instructive example is the Tunguska event of 1908, which, although occurring in a sparsely populated area, flattened over 800 square miles of forest in Siberia. This event demonstrated the potentially devastating effects of an airburst explosion, prompting scientists to refine their models of atmospheric entry and impact phenomena. The study of Tunguska has informed the development of strategies for mitigating airburst scenarios, improving our readiness to respond to similar events should they occur near populous regions. Moreover, the close flybys of asteroids like 2004 MN4, another name for Apophis, and asteroids such as 2005 YU55 have provided valuable data on the dynamics of near-Earth objects. These flybys offer an opportunity to test and refine our technologies, from tracking systems to potential deflection techniques, enhancing our preparedness for future threats. The lessons extracted from these past encounters are vital as we contemplate the possible close approach of Apophis in 2029. By leveraging the knowledge gained, we can refine our planetary defense strategies, ensuring that our responses are swift, informed, and effective. This concerted effort not only mitigates the immediate risks posed by celestial objects, but also fortifies our long-term capacity to protect Earth from the myriad challenges the cosmos presents. These lessons remind us of the need for constant vigilance and adaptation, fostering a proactive approach to planetary security that is both resilient and innovative. Preparing for the unknown when it comes to a celestial threat like Apophis involves a blend of scientific foresight, advanced technology, and strategic planning to tackle any uncertainties that might arise. Imagine a scenario where the unexpected forces of the universe suddenly intervene, altering the anticipated path of an object as unpredictable as Apophis. To address these potential unknowns, the scientific community is heavily invested in creating adaptable and flexible strategies. At the forefront of these preparations are continuous observation campaigns that monitor Apophis's trajectory in real time. These efforts ensure that any deviation from its predicted path is detected promptly, allowing for rapid adjustments in strategy. By employing an array of telescopes, radar systems, and satellites, scientists can gather precise data on the asteroid's position and movement, refining their predictions with each observation. Furthermore, the development of advanced computer models plays a crucial role in tackling uncertainties. These models simulate numerous scenarios, accounting for variables like gravitational influences from other celestial bodies or the Yarkovsky effect, where the asteroid's path is subtly altered by the uneven heating of its surface. By simulating these possibilities, researchers can prepare for a range of outcomes, ensuring readiness no matter how the situation evolves. International collaboration also forms a key component of this preparatory framework. With organizations like NASA, ESA, and the International Asteroid Warning Network working in unison, a global network of expertise and resources is at the ready to respond efficiently to any unforeseen developments. This collaborative approach facilitates the sharing of data and insights, enabling swift and coordinated action if Apophis's course changes unexpectedly. Additionally, discussions surrounding the potential use of deflection technologies are ongoing, with preparations in place to deploy kinetic impactors or gravity tractors if necessary. These technologies are designed to nudge an asteroid off its collision path, and by conducting rigorous testing and refinement, scientists ensure that they are equipped to act decisively should the situation require. Preparing for the unknown is an exercise in both caution and innovation, showcasing humanity's commitment to safeguarding our planet against cosmic uncertainties. As we advance towards the year 2029, the combination of vigilant observation, cutting-edge technology, and global cooperation stands as a testament to our readiness to face whatever challenges the universe might present. In summary, the looming presence of Apophis serves as a potent reminder of the potential threats that celestial bodies pose to our planet. This colossal asteroid, with its unpredictable path, highlights the importance of vigilance and preparedness in safeguarding Earth. Over the course of this video, we've delved into the discovery and characteristics of Apophis, explored the intricate dance of its orbital path, and examined the probabilities and potentials of its impact. We've witnessed the historical precedents of cosmic events and acknowledged the global response strategies designed to protect us. The scientific community's dedication to developing advanced mitigation techniques underscores the vital role that technology plays in understanding these cosmic phenomena. As Apophis approaches its close encounter in 2029, the necessity for international collaboration and continued observation becomes increasingly clear. The combined efforts of space agencies, scientists, and even citizen scientists form a robust defense against the unknowns of our universe. Yet, beyond the science and strategies lies a crucial task for all of us: to remain informed. By engaging with space science discussions and supporting planetary defense initiatives, we take an active role in protecting our future. As we ponder the mysteries of the cosmos, let us also celebrate the wonders of human achievement and our capacity to face challenges with resilience and unity. If you found this exploration into Apophis intriguing, consider subscribing to our channel. By doing so, you'll stay updated with the latest in space science and technology. Don't forget to like this video and hit the notification bell so you never miss out on new content. Join us as we continue to explore the vast universe and the steps we take to navigate its challenges. Thank you for watching, and until next time, keep looking up.